Hello everyone, welcome to the HCIP OpenELR certification course. Now let's continue to learn about OpenELR storage management. Previously, we have learned the technical principles of Gluster FS. As we can see from the technical principles, many storage servers are required to implement Gluster FS operations. Therefore, we need to complete more basic lab configurations. In this section, we will lead you to build the basic environment. Finally, you need to create a replication value to briefly introduce the value creation process. Let's learn how to build an environment.
In this experiment, 7 ECS are required. Node 1 to Node 6 are used to simulate the server of Gluster FS distributed storage. In addition, Client 1 is required to simulate the client that accesses the distributed storage. Now, let's complete the corresponding operations together. First, let's look at the corresponding disk information. Enter fdisk-l. In this, we can see that it has an 11 gigabit disk of DV-VDB. This disk is the disk we used for the Gluster FS experiment. We have introduced 5 distributed volumes in this course. If only one experiment is performed on one volume, 5 logical disks need to be created for each node. Therefore, we need to partition the volume accordingly. And in this, we can first look at the experiment guide. In the lab guide, we can see that it creates 6 VBS, among which VBS4 is not the normal VBS. And then let's look at what it's used for. From Node 1, Node 2, and Node 3, VDB1 is used as a distributed volume, and VDB2 is used for replicated volume, and VDB3 is used for distributed replicated volume. And then VDB5 is used for dispersed volume, and VDB6 used for distributed volume. Then the VDB1 of Node 4 and Node 5 is used as a test volume. Then the VDB6 on Node 4 and Node 6 is used as a distributed volumes. Okay, after we introduce the information about the corresponding VDB planning, you need to partition the corresponding VDB subvolume on the device. Now let's perform related operations. fdisk dev VDB, in which we need 5 partitions in total. Select the primary partition P. The default primary partition number is 1. You do not need to enter the primary partition number and press Enter directly. If the sector is used, select the default value. After the space, each partition is 2 gigabit, so select 2 gigabit, write, and exit. After the partition is complete, we can take a look at it. After querying, we now have a 2 gigabit partition. Then we finish the rest of the partition. I will not explain the repeat operation in this section. Continue to complete the creation process. When we created the 3 partitions, let's check them first. Here I have created VDB1 through VDB3. In this, we need to note that I create 3 VDBs, 2 gigabits each, so I have 5 gigabits left. And then we were going to create the 4th one, and we were going to find a little problem, fdisk. And then you were going to notice that we have only 1 primary partition left. And we were going to have create VDB5 and VDB6 later. Therefore, at least 2 partition numbers are required. Therefore, the 5th and 6th VDBs cannot use the primary partition, but only the logical partition. Therefore, we do not select P, but E. Then we configure our sectors and space according to the planning. At this time, we will find that in addition to VDB 1, 2, 3, we have generated a VDB4. However, VDB4 is a logical partition, so its space is only 1 KB. The VDB5 and VDB6 are created in logical partition according to the experiment guide. VDB123 has 2 gigabits and VDB4 has a 5 gigabit logical partition. The remaining space is located to VDB5 and VDB6. But since it has no actual space, it only shows 1K. After that, VDB5 and VDB6 are mounted to VDB4. So VDB5 and 6 are logical partitions. Now let's finish creating the rest. When I create VDB5, we find that after entering N, we can no longer select the primary partition of P and the logical partition of E, that is 5. Then press Enter and enter 2 gigabit to complete the creation. And then we continue to complete the creation of 6. Okay, after we finish creating the partition, let's take a look. Here you can see VDB 1, 2, 3, 5, 6. Therefore, the space of 5 VDBs is 2 gigabit. Now we have finished creating the partition on node 1. Next, let's create the partition on node 2 and 3. Okay, everyone. Now I have finished creating 6 node partitions. We can look at node 6 partitions from 1 to 6, node 5 partition, node 4 partition, and 3, 2, and 1. And we finish creating the partition. After the partitioning is complete, you need to format the partition in NFX format. So we enter makefs.xfs and enter the corresponding disk to complete the disk formatting. And then we format all VDBs on all nodes by this way. After formatting, enter BL block KID to check whether the formatted disk type is XFS. So the formatting is successful. And then we query node 1 again. The display is also normal. And then we need to mount a partition. Before mounting the partition, we need to create the corresponding mount point. So we run make directory -p command to create VDB1, VDB2, VDB3, 5, and 6 at the end of the exp folder. And after the mount point is created, you need to mount the disk to the mount point. Now mount DEV VDB1 and mount VDB1 to exp VDB1. Then we mount all other nodes to the mount points in this way. Okay, now we have finished all the mounting operations on node 1 to node 6. After mounting is complete, you need to complete the automatic mounting upon system startup. As we mentioned before, if automatic mounting is not set in during mounting, the mounting becomes invalid when it restarts. Therefore, you need to set automatic mounting upon startup. The corresponding file is stored in fstab. So we go to etc and query the fstab file. Currently, only the default mounting information about the device is displayed. The mounting information is not displayed, so we need to use echo to edit. And following the same rules to complete the other mounting operations. Now we will finish configuration the automatic mounting on startup. And next, we can perform Gluster FS related operations. First, we need to create a Gluster FS break. In other words, we need to share the break at the resources in the storage pool. In this, we set the break as a subdirectory. This subdirectory is created under the VDB we just created. So first, make directory, create a break in exp vdb1, and this break can be shared as a subdirectory. Then we cd and goes in. Okay, the break is created successfully. And then we need to complete the configuration of other VDB breaks. VDB 2, 3, 5, 6. And after that, we can copy the command line to the other nodes. Okay, just now we created one by one on node 1 using. And you can also select the bench creation, such as make directory -p exp vdb1 /break, and then vdb2 /break. And then exp vdb3 break, vdb5 break, and the last one. After the creation is complete, we copy the command line to the other nodes. After the creation is complete, you can manually check whether the input is incorrect. So after we create the break, we do a host name mapping so that we can identify it more easily. Currently, there are 6 nodes and the IP address of each node is different. To facilitate identification, we map the IP address to the host name. The mapping information is stored under the host. So let's go to editing. 192.168.1. The following IP address is the IP address of the peer end. Therefore, we need to query the IP address of our own. First, we need to query the IP address for our own. It's 1.37. So let's put the mapping information under the etc host. Then I copy the mapping information to other nodes, and so on we complete the mapping of node 1, 2, 3, 4, 5, 6. Now I have completed the command input for all mappings. Let's run a test and pin node 1. It can be pinned. And try other nodes, node 2, 3, node 4, 5. And all the nodes can be pinned. And why are we testing in these things? Because network connectivity is necessary for GlusterFS to create an environment properly. If we don't pin through this, there are two possible reasons. The first is that my IP address is wrong. Second, it is possible that the network in middle is not connected. So here everyone needs to pay attention. And next, let's install the GlusterFS component by typing yum-y install GlusterFS-server. After node 1 is installed, the components of node 2, 3, 4, 5, 6 are installed by this way. Now I have installed all 6 nodes. And after the installation, we need to set up the boot and check the corresponding status. We run the system control start gluster command. And notice that the GlusterD is used here. After the startup is complete, enable GlusterD. Then we query the status. Now the status is automatically started and the service status is started. In this way, we can perform the same operation on other nodes to copy the command directly, saving time. After the installation is complete and started successfully, you can create a distributed storage trust pool. The command for configuration the storage trust pool is cluster peer. When I enter cluster and PE performs tab supplement, there is no response. The possible cause is that the corresponding bash package is not installed. Therefore, install the bash package and restart the system. So first we install the bash package and then restart the system. After the restart is complete, we log in and see if we can use Gluster to complete the peer command supplement. Enter cluster and enter PE and press tab. It's work. And then the command for adding the storage trust pool is to write the node to be add after probe. And we will just create the host mapping. So in this, we just write node 2. The storage trust pool is added. Because distributed storage is running on all 6 nodes, other nodes can be automatically identified as long as one node is successfully added. Therefore, I only need to add the enter distributed storage trust pool on node 1. And then we finish 3, 4, 5, 6, and 1 in order. And when I add 1, because I added on node 1 myself, so it promotes me that I do not need to add it locally because I have already added it. And after the storage trust pool is added, you need to check whether the storage trust pool has corresponding information. We enter cluster pool and then list. We can find that the node 2, 3, 4, 5, 6 and myself are displayed. And then you can go other nodes to check whether the trust pool information is consist. Enter cluster pool list. If node 1, 2, 3, 4, and 5 and a local node are displayed, the node in the trust pool are added successfully. At this point, we have the break and storage trust pool in place. Now, we will going to start creating a variety of volumes. Before we start creating distributed volumes, let's create a test volume. To create a test volume, run the cluster volume and then create command to add the name of the volume to be created. And here we write it as test-volume according to the lab guide. And in this case, the test volume we created is a replication volume. To replicate a volume, you need to configure replicas and specify the number of replicas. If the value is 2, 2 replicas are created. If the value is 3, 3 replica is created. In this, we write 2 copies. The 2 copies need to match 2 bricks, so the link to the bricks continues to be written later. The node exp vdb1 brick for node 4 and exp vdb1 brick for the second node, for the second brick path of node 5. To sum up, the command for creating a volume is in the format of cluster volume operation. For example, create indicates the name and type of the volume, such as the replication volume. And finally, the location of the volume. And then we press enter. Yes, the creation is successful. After the creation is successful, we enter Glossar Volume E4 to view the creation information. Let's take a look. And the first one, test, is the name of the volume. The second indicates the type of the current volume. And in this case, the type is replicated, indicates the volume is replicate. If the status is created, the number of breaks is followed by the number of breaks, that is the numbers of blocks, and the protocol type is TCP. And here, break 1 and 2 are the two breaks that we just added. The current state is create, so we need to go and start both volumes now. So we type Glossar volume start, and then volume name to start the volume. After press enter, the system promotes that the startup is successful. Now, let's look at its info information. And it's in the starting state. Now the volume is in functional. So far, the distributed storage server has been configured. Next, we need to configure the client. That is, we need to configure the client 01. First, we need to install the distributed storage client. Yum install GlossarFS. GlossarFS does Fuse. This is its client component. As we said about Fuse, it is the process of the kernel. If I want to access the underlying distributed storage, I need to access the Fuse through this process. Therefore, I need to install the Fuse. After the installation is complete, you need to map the host name as before. Since we were already mapped, so let's look at it. Here you can see the IP address of node 1 to 6, so we do not need to map it. And now that we want to use distributed storage, we need a mount point. Therefore, you need to create a mount MNT and GlossarFS GFS and test directory. And then we check after creation is successful. You can see the mount directory. And then we use mount-t command. The mounting type is specified and the protocol type is specified. Therefore, configure GlossarFS and then mount the created test volume. And then write node 1 test volume. And write the file to the mount point MNT GlossarFS and test. and repeat it again. -T is the type after mount. Gloucester FS is the IP address of the volume. And finally, the local mount point. After the mounting finished, we run the df-h to view the mounting result. Here you can see the mounting point, so we are finished the mounting process. Let's try we touch a test.txt and add the file. We enter Clyde01 and save the file. Then we switch to the distributed storage and check whether the brick has its information. When we created it on node 4 and 5. So we run the info command to check whether the brick of the test volume are on the node 4 and 5. Then we go to node 4 to check whether there are newly written files. So go to expvdb1 and brick and query the test.txt. And then run cat command to view the content of Clyde01. This indicates that the mount storage space can be used normally, and we can also see the file on node file. And here, this is node 5, and also we can see the file on node 5, indicating that the experiment is successful.
In this section, the basic environment has been set up and a replicated volume has been created. Through this replicated volume, we can briefly learn how to create a volume in the next section. We will introduce how volumes are created, including distributed volume, replicated volume, and distributed replicated volume. Thank you for watching.